All right, in this video, we're going to look at some more examples using the double angle identities. So example 2, we have sine of theta is x, and theta is between negative pi over 2 and positive pi over 2, inclusive. And we're going to find an expression for sine of 2 theta in terms of x. So first, let's get an idea of where we are. With theta between negative pi over 2 and positive pi over 2, that could either put it in the first quadrant or in the second quadrant. So here we have a case in the first quadrant in red and a case in for the second quadrant in blue. So sine of theta is x, which means x over 1 or opposite over hypotenuse for each of these two cases. So sine 2 theta is going to be 2 times the sine of theta times the cosine of theta. Well, we already have an expression in our figure here for sine of theta. This should also, by the way, it could use negative x here, although it's not the most important thing in the world right now. But we do need an expression for cosine theta, which means we need to find, for this adjacent side, we need to find an expression for it. So we'll call it A for adjacent. I'll just use the first quadrant here as, so we have cosine of our angle is A over 1, which is A. And if we figure out what the value of A is, we can use that for our cosine. So Pythagorean theorem says A squared plus x squared is 1 squared. Well, if we subtract x squared from both sides, we get A squared is 1 minus x squared. So then take the square root, we get plus or minus the square root of 1 minus x squared. So in this case, because we are on the positive x-axis, A is going to be the positive square root of 1 minus x squared. If we were on the negative x-axis, we would use negative square root of 1 minus x squared for our value of A. So A is positive square root of 1 minus x squared, which means the cosine of theta is the square root of 1 minus x squared. So here again, we see now we have it labeled 1 square root of 1 minus x squared for our adjacent side. So with sine of 2 theta equals 2 sine theta cosine theta, 2 times, we know sine of theta is x, and we now know that cosine of theta, we can substitute the square root of 1 minus x squared. All right, example 3, verify the identity that sine of 2 theta is equal to 2 tangent theta plus 1 plus tangent squared theta. So seems like there's a typo here, but there actually isn't. The sine of 2 theta does equal this 2 tangent theta over 1 plus tangent squared theta. So sine of 2 theta is 2 times the sine of theta times the cosine of theta. And if we express tangent of theta as sine over cosine on the right-hand side, in the numerator, we get 2 times the sine of theta over cosine theta all over 1 plus the sine squared of theta over cosine squared theta. Well, we have a complex fraction here, so if we multiply the entire numerator and entire denominator by our least common tiny denominator, it'll clear out these fractions within fractions. In this case, our least common tiny denominator is cosine squared. So if we multiply everything by cosine squared, it'll clear out these tiny fractions. Doing that, we get 2 times sine of theta. The cosine in this denominator, this tiny denominator, is going to cancel out one of the cosines here, leaving us with 2 times sine theta times cosine theta in our numerator. In the denominator, we get 1 times cosine squared is cosine squared, and then sine squared over cosine squared, multiplying that by cosine squared. The cosine squareds divide out to 1, leaving us with just sine squared. And our denominator, we have cosine squared plus sine squared. That'll equal 1 no matter what the value of theta. So on the right-hand side, we have 2 times the sine of theta times the cosine of theta, all divided by 1 gives us 2 sine theta cosine theta, which is what the sine of 2 theta is. All right, example 4, express the cosine of 3 theta as a polynomial in terms of cosine theta. So normally with polynomials, we see things like 5x squared plus 2x minus 1. This would be something like 5 times cosine theta squared plus 2 times cosine of theta minus 1, or something to that extent. So that's what it means when it says expresses a polynomial. So cosine 3 theta, we don't have a formula for it, at least not right now, but it's the cosine of 2 theta plus theta, because 2 theta plus 1 theta gives us 3 theta. Now for this, we have the cosine of our first angle is 2 theta, our second angle is theta. So 2 theta in our formula would be like A, and theta would be B for our angle sum for cosine. So we take the cosine of the first angle, multiply it by the cosine of the second, so cosine of 2 theta times the cosine of theta, and then minus the sine of the first angle times the sine of the second. So minus the sine of 2 theta times sine theta. Now, in terms of the cosine of 2 theta, since we want everything to be in terms of cosine, we have three different ways of expressing cosine of 2 theta. We're going to use the one that just has cosine, the 2 cosine squared theta minus 1. And again, that's because we want to express everything in terms of cosine, not in terms of sine or sine and cosine. So cosine of 2 theta here is 2 cosine squared theta minus 1. And then sine of 2 theta is 2 times sine theta times cosine theta. So in red, I've substituted in those identities for cosine 2 theta and sine 2 theta, respectively. Distributing this cosine to the first two terms, we have 2 cosine cubed theta minus cosine theta. And then we have 2 sine theta cosine theta times sine theta. That'll give us 2 times cosine and then times sine squared. So we're still not done yet because we have a sine here. We want everything in terms of cosine. So going back to the relationship between sines and cosines, that alternate Pythagorean identity number 1, that sine squared, we can rewrite as 1 minus cosine squared. So we can rewrite sine squared as 1 minus cosine squared, and now we can distribute this negative 2 cosine to each term. And we get negative 2 cosine theta, and then positive 2 cosine cubed theta. So negative 2 cosine theta times negative cosine squared theta gives us positive 2 cosine cubed theta. Now just combine our like terms, and 2 cosine cubed plus 2 cosine cubed gives us 4 cosine cubed. And then negative cosine minus 2 cosine is negative 3 cosine. So our final answer, as far as now we have an identity for cosine of 3 theta in terms of nothing but cosine, is 4 cosine cubed theta minus 3 cosine theta. So if we needed to use this, we can just substitute our values in here and simplify. All right, that about does it for this video. Thanks for watching. I'll see you next time.